Welcome to NM Galaxy. This is NLP tutorial part 5. In our previous class, what we saw was how to represent NLP problem and how to convert textual information into a meaningful features. For the NLP model, the input information would be in terms of text. Let us assume that this is the corpus, which will have number of sentences, and we need to convert this into meaningful features. We saw this, how do we convert this information into the meaningful features, x1, x2 up to xm. Now in this class, how we can reduce the dimension of this input vector. So the number of features in this representation is v, which is equivalent to the size of the vocabulary. The vocabulary means unique words in this entire corpus, which varies from 1, 2, 3 up to m. So we saw the issue with this representation. It is very sparse and the size would be very huge when the corpus size is very big, and it would take longer time to train and tune the parameters which is appearing in our mapping function f of x. All the information that goes into f of x is the input vector x1 up to xm, and then we need to train our model. We need to tune the parameters theta 1, theta 2 up to theta m, and it will predict the sentiment of each sentence, whether it is a positive sentiment or negative sentiment. So we are going to see how we can compress this information. Instead of using x1 to xm, how we can reduce the dimension of this vocabulary. So we need to follow some pre-processing steps. We will see one by one. So usually the information, when the data is being collected, how the textual information is entered in social media is just we will enter our comments in a text box. So here example is, I liked the movie. This is entered inside the text box. Now the first step is we need to just take a sentence. The first sentence is, I liked the movie, comma, the movie was awesome. So the first step would be, and there might be some URL to the movie link, and then .xyz something .com, or there might be some email address. So the first step in the preprocessing step is remove these URLs and this kind of IDs. And then once we remove this one, our sentence would be like this: I liked the movie, comma, the movie was awesome. Next one is tokenization. Second step is tokenization. What is this tokenization is? Just convert the sentence into a small single words as a list. So this is a textual information, a whole sentence. Just cut these sentence into a separate words. I liked the movie, comma, the was awesome. So this is our first step, and then second step, tokenization, and third one is removing stop words and punctuations. Why do we do this? So when I look at this list, some of the words are not relevant for my sentiment analysis. So here the word, I look at the word I. How do I classify I, whether it is a positive sentence or negative sentence? How much value this I is giving towards my prediction? So it has no value added. So this is the meaningful features when I add into my feature list. So I would be removing the word I. So likewise the, again the, and then I do see the punctuation, that comma, and this was. So remove all these stop words and punctuations. So once I remove this, my list would be reduced like this: liked, movie, movie, awesome. Next step, step number 4 is stemming and lemmatization. So what we are doing here is, in stemming, we just take the root word. For example, when I look at the word liked, the word liked is very similar to the root word like, liking. So when I read the entire corpus, when I create my vocabulary, there might be three words, three different words: like, and liking. So different sentences may have different words like this. So instead of using all these three features, we can create a root word like. How do I do that? Instead of using all these three words, using stemming and lemmatization. So in stemming, what we do is just cut this ed, e, and ing, and the word would be like. So, but original word, that meaningful word of this one is like. So the stemming would do this part, and lemmatization would do this part. So convert into human readable word. But in some model, we do not worry about this lemmatization. So in our sentiment analysis, what is our goal? Our goal is to predict the sentiment of any sentence. So here the input information is the movie review. I liked the movie, and see the sentiment associated with this sentence. It is positive. The model should predict this as a positive review. So when I feed this information, I would be creating these features x1, x2, xm, reduced number. One of the x would be like after stemming. So when I feed this information into this f of theta, it would predict the sentiment. So as a user of this model, I would be actually interested in only what is the final outcome. I'm not worried about the word like or like. So in this type of models, we do not need to do lemmatization, just leave it as it is, only use stemming. In some other model, we will see those type of model in later classes. In those models, we would be looking at the output. Output would be a kind of another sentence. So in those type of model, we need to do lemmatization as well. So these are the preliminary pre-processing steps involved in NLP, data pre-processing. So initially we saw our vocabulary was like this. Yeah, so before that I forgot one more step. After stemming and lemmatization, the step number 5 is convert into lower cases. So the sentence may have a word happy, another word happy. The first one is in capital letter, another one is happy. So when I look at the data, there might be 3 features of the same meaning, happy. So instead of creating 3 features with a different capitalization, I just convert all these 3 into a lowercase, single word happy. So this is how we can reduce the dimension of the input vector. So after I apply all these 5 steps, my input data dimension would get reduced. So we can see the example. So initially the vocabulary sizes, I liked the movie, it was awesome, hate, boring. How many words it has? 9 words. So input vector size is 9. So the number of features means variables. The number of features in this is x1 to x9. So after applying all these pre-processing steps, 5 steps, we end up with a smaller vocabulary size. One is like, like, movie, awesome, hate, bore. So now the size of my vocabulary is only 5, x1 to 3. So after I convert this into the 5 dimension, my my representation of the input vector or feature vector would look like this. So I have the feature vector x1, x2, x3, x4 and x5, and x1 represents the word like, and this one is movie, awesome, hate, bore. Now I'll do the conversion, feature vector creation, which is called as feature engineering. One of the feature engineering method what we saw in our previous classes, bag of words, that's binary bag of words. What do we do in binary bag of word is just create this feature, binary features, which has values 1 or 0. Now we have sentence 1, movie review sentence 1, sentence 2. Sentence 1 is I liked the movie was awesome. So like was appeared in my first sentence, movie was appeared in my first sentence, awesome was appeared, hate and boring was not appeared. When I look at my second sentence, like was not there. The second sentence was I hate the movie, it was boring. So like was not there, movie was there, awesome was not there, hate was there, bore was there. So and my output vector is this one is the positive and this one is negative. This is how I represent my feature vector. This method is called binary bag of words. So now we know how to pre-process the data and how we can reduce the dimension to some extent and get meaningful features. So this is the meaningful information that we can use to train our model, and the model can predict the sentiment of the class. Now in our next class, what we would be seeing is word embedding techniques. So word embedding means just convert the words into a meaningful numerical vectors, numerical representation of those words. So one of the embedding technique what we have seen here is just binary bag of words. There are a few different techniques which is more meaningful and more powerful than this method, binary bag of words. So we will see all those techniques in our next class. Thank you so much. Bye.